welcome back to Housebuild TV. Tonight we're going to look at approved document C, which is site preparation, resistance to contaminant and moisture. So welcome back, Geoff from Wilkinson Construction and Eoghain Ryan from housebuild.co.uk and Ryan & Associates. Let's get started.
Okay, brilliant stuff. Good to see you folks again, and yeah, the plan tonight is to dive into part C, which, as you said, is about contamination and resistance to moisture. The document itself kind of divides reasonably sensibly into two sort of portions. The first half of it is really about site investigation and the risks on site, and then the second section is really about how you detail the building, the floors, the walls, the roofs against the contamination, the moisture getting into it. So that's kind of how I see that we'll run through tonight. So let's start with that, the first bit. So the first bit really starts off with the concept of undertaking a proper site investigation. Now, this is something that, particularly on like the domestic extension side of stuff, rather than a full new build house, often gets forgotten about. Now, I know that we mentioned it briefly in when we were talking about part A, about checking for drains, things like that. But there's a lot more to site investigation than just that. So some of the things that you can do, what's known first of all as a desktop study. Okay. Now, a desktop study involves looking at the available geological and environmental information that you may have about the site. So you're looking at things like what was the site used for previously? Was it a petrol station, for example? Was it a car wrecking yard? What's gone on this site in the past? Because that may give you an understanding of some of the risks that you'll be detailing against. One of the things that you quite often have is that the sites that are available are brownfield sites. So they'll have some kind of past history. It may be that they're adjacent to a landfill site where you've got waste and rubbish that's been decomposing over time, and there are risks associated with that. It might be it's a former coal mining area. All of this kind of information, if you take some time, even without having gone to the site, you can start to find out what else is in the area, what is the history, what type of soil do you expect. So there are soil maps of the UK that you can find. Even in the approved document itself, it gives you a very brief generalized map of the UK, identifying things, for example, like clay soils that have a high shrinkability. So you can get quite a lot of information without necessarily having got someone to go to the site and start sampling the soil itself. If that first desktop study starts to show, actually, we might have some problems on this site, then absolutely you need to be doing a more detailed investigation. Now, that normally involves getting a specialist company in to dig some boreholes or trial holes on the site and do some investigation into what you might actually have on that particular site. And they'll be looking for things like chemicals, contaminants, gases, what the soil itself is, whether there's previous fill. So all of those bits of information really need to be incorporated into your design report. Right.
Yeah. Geoff, with that, people need to realize, I think, that the cost of doing those kind of studies where you're getting a specialist environmental engineer out to check the soil can be very costly. And like you said, they're mainly prevalent with brownfield sites, not with a greenfield site, unless the greenfield site is after in an area that it could potentially be contaminated. But you generally get these issues in brownfield sites in cities or where there has been landfill. But the cost of doing it, I know, like in Ireland, it can be it can be dependent obviously on the size of the site or the amount of contaminants, but it can be expensive, with anything from 3 to 15,000 in getting that piece of work done. And then if they are contaminated, I'm sure Geoff will allude to that the cost of making that land good can be significant, and you could be talking up, like a cost in Ireland maybe could be up on 100k, it could be more, but it's not it's like what you might feel is a good deal with a brownfield site may not necessarily be. And your margin and the price of getting to ground to build can be very expensive, but before you know it.
Yeah, I mean, it's really weird because I think generally speaking, the bigger sites that you've got like that do see the value in doing some of those things. But we've even had issues in the past with fill, for example, on sites. I remember working for one local authority years ago, and literally the road was called Brickworks Lane, or very similar to Brickworks Lane, and that gives you an idea of some of the history of the site. So when they actually started digging down on this particular site, and it was only for like a domestic rear extension, they found lots of broken brick rubble for the first metre. Which had basically been some of the spill waste from the brickyard itself had basically been dumped into this area of land. We've had another one which is like highly unusual. We had pirate caves. They'd actually dug down on site. They hadn't sort of looked at the history of the site. This is just for a domestic extension, and discovered that there was tunnels and a pirate's cave underneath where they were planning to do it. So even on some of the really small projects, it's bizarre how much that if you just look at the history of the area, or some of the, that wasn't called Pirates Lane, by the way, just to be clear, it wasn't as easy to spot as that. But if you read some of the historical bits, this was an area where there were basically hidden tunnels that used to run through, where the pirates literally ran through from one zone to another to avoid kind of capturing. So it's just like this is really weird kind of stuff that's gone on, which is it's highly unusual. But if you do read the history of that and read what the road names and stuff are within that area, it may well give you some information on it. I mean, we've worked on areas that were former gasworks. We've worked on areas where there are deep peat fill sites. So there's a big peat layer which will expand and contract very significantly. We've worked, as I say, on a former nuclear powered submarine dockyard. So there's radioactive material within the ground itself. And to remediate any of those things are going to be particularly expensive. So as Owen was pointing out there, to try and make sure that you've done that little bit of research, that little bit of history on the area, the road names, etc., could save you some massive issues and massive problems. Sometimes you just still get caught out, but the more time and effort you put into researching it, the less likely you are to get caught out. So sometimes it can be as simple as just looking for things like the street names and understanding, like Brick Lane could have particular meaning. So those are some of the examples that can really help give you an idea of some of the things that you may be encountering there. Another thing to look out for is if you can find particularly like in areas like London, where the historic bomb maps were, because a lot of the areas can have unexploded ordnance, for example, to it. Don't know if I've mentioned it before, but literally the site across the road from our offices in Kings Hill, they discovered unexploded ordnance from the Second World War. We're based on what used to be an airfield. So they were digging down and suddenly discovered, oh, hang on a second, we might need to stop now and evacuate out. It's a great way of excavating a very large hole on your site if you really need to, but probably not the best of ways of doing it. So anyway, having established what you have got on site, then you start to out some of the things that you need to do about it. So one thing you can look for, even without having done a detailed research, is are all of the plants on the site dying off, for example, because that will give you an example of the issues that you'll kind of find. Yeah, have you got any unusual smells or colours or anything like that to the soil? If you're finding those are usually a good sign that you need to do further investigation. Once you've found them, then that's where you then need to either cap the site to prevent the contaminant getting through, or you need to remove the contaminant from the site, which is you either cart it off, and that obviously becomes very expensive as well if you're taking contaminated material off site. It's not unheard of to find buried asbestos in some of these sites as well, and needless to say, that becomes again a very expensive thing to do. Also, I mentioned like landfill sites being nearby. Now, landfill sites can result in methane passing through the ground strata layers and up into your site. So sometimes you may need to do a check for gases on the site, because you can find gases from the ground actually coming up through the soil and into the building itself, and then you need to put a methane barrier, for example, in place. Depending on what area you are, and traditionally and typically in the past, sort of the Cornwall and southwestern area, you get quite a lot of risk of radon in those areas, but they're not the only areas that have radon to them. So again, there is a UK-wide radon map, which does help you to understand whether there's a risk of identifying radon on the site. And that's another area, again, where you then have to put another barrier in. You probably need to ventilate the subfloor zone to ventilate that gas out, so that it's not going to be a volatile substance that you're breathing in to your site. That's quite difficult to establish without doing an investigation.
Yeah, it's very prevalent in Ireland. So what happens in Ireland, your DPM and your radon barrier generally double up as one. The product that made is a certain type of gauge, 1200 gauge generally, and we have a radon sump below it, which prevents it from under the layer. But well, in Ireland, where we're from, nearly every house has to have a radon barrier. It's probably not the same in the UK, but it's something we have to bring into all design. And it generally doubles up as your normal DPM anyway. Yeah. So that's how they've done it.
Yeah, that's again typical of the way in which it's dealt with. It's just identifying whether or not it's something that you need to incorporate in your design or not. Again, it adds to the cost of the building. The next part of it is also to take a look at groundwater. Now, building regulations don't per se deal with flood risk assessment. But ideally you want to have done some flood risk research anyhow. But one of the things to look out for is, are you likely to be cutting across a site where there's groundwater movement within it? Because you'll then need to create subsoil drainage. Otherwise, you'll end up with increased amounts of moisture or groundwater potentially driving into your site itself. And that's something that's quite often forgotten about. I know that we've mentioned it when we've been talking about basements, for example, but even times where you could have a subsoil drainage field, so like a French drain, running through the site, and what's happening is you're effectively going to be building straight through the middle of that, and that can result with localized flooding to your site if you're not aware of it in the first instance. It's always better to have researched and tried to prevent that before you actually get to site, as we always say. So that's sort of parts 1 to 3 of the approved document, which is all about the research and making sure that you know what you're dealing with. Parts 4, 5, and 6 then start to look at how you go about the detailing and solutions for it. So if we start off with the floor itself, this is where we're looking at the provision of the damp-proof membrane. Okay, now if you have a ground supported floor, then you'll normally put some hardcore down. You're likely to then blind that, so you've got a nice smooth surface to put your membrane down onto. Alternatively, you might choose to put your insulation layer at that point and then place your membrane on top of the insulation layer. You need to be sure as to whether the type of insulation you're proposing to use can be used above or below that damp-proof membrane, because if it needs to be protected from the damp, the insulation needs to be above. If it's suitable for use below, then it can be used below, which helps to take out part of that blinding issue, perhaps. You have got traditional, and I use the term loosely, traditional suspended timber floors. That's where you would have what we would talk about honeycomb sleeper walls. So you'd put down an oversight, a simple oversight concrete, and then you provide ventilation to that timber floor. Now, if you're doing an extension to an existing dwelling, if you've got an existing timber floor, and you then decide, well, on the extension, I'm going to put a concrete floor down, then you can end up with the new extension closing off the air bricks that were providing the ventilation to the timber floor and causing damp within that. So if you've got that situation and you decide you don't want to keep a timber floor in the new bit that you're building, you want to go for a concrete floor, then you need to make sure that you're ducting through to maintain the ventilation through to those air bricks. Okay, yeah. Now that can be done through simple pipes in inverted commas, or cranked air vents that go through the cavity and down. If you are breaching the cavity itself, then you'll need to have a tray over that, and that's an important part of the detailing of damp proofing, and that's where really part C comes into huge effect. A lot of people don't really understand about the detailing of damp proofing. So you can have air bricks that are running through, you could have services that are running through. Any of these, if you've got a cavity wall, will cause any moisture coming down the cavity to potentially run into the building rather than out of the building. So that's where you would be looking to have what we refer to as a cavity tray in place, which will divert any moisture coming down the cavity outside the building. And whenever you have a cavity tray, you should always have a weep hole to ensure that the moisture that comes down can actually be directed outside and away from the building. Quite often they're forgotten about with beams, lintels, reveals. So there's quite a lot of occasions where you've got those kind of important details. Anywhere where one leaf connects to another leaf are examples of where you need to ensure that you're getting like a vertical damp proof course in place. Otherwise, you can end up with moisture bypassing from the outside of the building to the inside of the building.
The cavity tray, Geoff, is generally it's generally about 150 mil above the outside finished floor.
So the damp proof course itself, that's a very good point that you're making there. The very general, and this has been the case for forever, as far as I can ever remember. The idea is that you have 150 mil or 6 inches between the ground level and the level that the damp proof course is at. So that would be the base level of the tray, and then the tray would be above that down to the main damp proof course that's at 150 mil. So why do we put the damp proof course 150 mil away from the finished ground level? Well, that's predominantly to stop leaves, dirt, etc. building up against the side of the building and then bridging that damp proof course, because otherwise it doesn't take an enormous amount to get to the point where that damp can travel across and bridge the damp proofing arrangements that you've put in place. Yeah, so that's something to I say look at in particular is that detailing. If we can make sure, as I say, that the trays are in place and there's no route for the moisture to get from the outside to the inside. There is a situation that you can have where there's a clash between what one regulation says and another, and that's about having level access. So you may well find that for Part M, you need to provide level wheelchair access from the outside to the inside. So having that step up of 150 millimeters is not really practical. So this is an area where you can have like a French drain around the outside of the building, or a cavity drain type system, which will allow you to have the finished levels of the ramp or the external works level with the level that you've got inside the building. And that's quite a popular detail for people to want to work, both for new housing and just because they like the idea of almost this seamlessness of the inside going to the outside. So there are a couple of details in particular around that that perhaps we'll touch on more when we talk about Part M. So that's dealt with the moisture coming from the floor and from the ground, but you'll also get potential for moisture to come in through the roofs themselves. Now, obviously, you're going to select a roofing material in itself that helps to prevent that, but damp detailing of lead flashings and upstands around roof lights, things of that kind, are just as important as well. So all of those bits can end up creating issues where, if they're not detailed correctly, you'll end up with damp ingressing into the building. So, for example, a lot of people have seen lovely looking Grand Designs type properties where the roof light appears to be level with the surface of the roof itself. Now, the roof light should always stick out again by like 150 millimeters from the roof surface so that you can actually dress it with lead flashings, etc., to prevent moisture coming in. Because otherwise, if it's actually at the level of the roof light itself, there's a really weak join between the two. How are they achieving this where they're giving the visual of it actually being at that level? Well, quite often what they'll do is they'll actually put a false roof or like paving slabs over, so that those are level with the roof line, but there's actually a drained cavity beneath that, so you still have the upstand between the two. The detailing of lead flashings around chimneys, around junctions with other roofs are particularly important. Quite often we will see builders try and use a product that we refer to as flash band in the UK, which is basically a sticky flashing, looks a bit like metal but actually isn't, that just sticks onto the wall. Really, you need to chase a proper piece of lead into the wall to maintain that junction between where the felt of the roof comes up or where the tiles come along and into the existing brickwork of the main building. If you're not, you're creating a very weak join between the two, and that's where moisture can potentially get in over time. The final one that I really probably want to pick up on for tonight is about making sure that the tops of walls, so if you have a parapet, for example, running around the outside of a building, that you have a coping stone on the top and that you have a damp-proof course underneath that coping stone. And the coping stone should be sufficiently wider than the wall itself so that any moisture coming down or rain coming down onto the coping stone is pushed away from it. And then they have little nicks underneath that prevent capillary action from the moisture coming through and running under and into the top of the brickwork wall. So that's again an important detail to make sure that you're getting correct. and it's one that we frequently see as being an issue. It's particularly an issue in areas where you have highly driven rain. So coastal areas, typically areas that are high and exposed, you can end up with wind-driven rain that will be far more penetrative than, say, in the centre of London when you're surrounded by lots of other tall buildings. So the risk of moisture ingress into those situations is less than on the exposed coast. So again, looking at the maps of the UK and the exposure zones for those areas are particularly important as well. Certain insulation types in a cavity wall, again, are not necessarily suitable for having that. So if you end up having a full fill cavity, then that might be acceptable with a particular type of insulation, but only in certain exposure categories. So if you were in a coastal area or one of these areas that's more subject to this wind-driven rain, those areas would not be acceptable for that particular
Geoff,
type.
what kind of material would you think? Would it be a PIR? Would you be insulation in that instance, or would you be looking for an EPS full fill, or like I'm sure Rockwell or mineral wool certainly wouldn't be suitable there. So what would you think would be a suitable insulation material?
Yeah, so what you need to do is you need to check on the manufacturer's details as to what particular product it is. Now, in most cases, even the PIRs or the EPS type products aren't necessarily going to prevent moisture ingress through if it's a full fill. What you'll typically need in those situations is a product that specifically has broken joints, so it's like a tongue and groove, to prevent the moisture going through like a straight joint. One of the things that's important with any of the insulations is to check whether you need to tape those joints to also prevent moisture ingress in. And although it's not necessarily super relevant to Part C itself, one of the other risks of moisture is actually through interstitial. So you need to do a risk to ensure that whatever build-up you've got, so if you do leave a partial cavity, or you put some insulation on the inside and some insulation on the outside, for example, that you're not going to end up creating more of a problem with damp ingress into the building. And when we touch on Part D in the next one of these, I'll talk about how inappropriate insulation and retrofit can actually cause you massive problems with your damp proofing design, because you've moved away from what you would have traditionally in place. So it's always important to make sure that what you're doing by improving the insulation doesn't create more of a problem by actually causing damp within your building, because we've certainly seen that. But tune into the next exciting episode to find out more about how you can prevent that. For those of you that have been, for those of you who have been listening, I've been Geoff Wilkinson. Thank you very much.
Geoff, that's super. And just as a recap, of anyone listening, take note of the place names, do your research, make sure your ground conditions are good or it may cost you money, and then take on board what Geoff is saying about coming up from ground at roof level, coping stones, and then in a cavity, because the last thing you want is dampness, because that generally costs a lot of money in remedial work. And get it right first time, don't have to go back and do remedial works. But that was brilliant, Geoff. Thanks so much.
Thank you very much. And I say it's important to get your architect to do the detailing, because otherwise a builder can come in, not understand or think that they've done this before and they'll do a certain detail. But actually what you need is the right detail for the products that you're using on your particular build. So always make sure you're double checking and make sure the detailing has been done so it's clear what's needed.